For number 23, we're going to find the center. And the center is at 4, 1, and the radius squared equals 1, so the radius is going to equal 1. So a positive 4, positive 1 for your center. Then you go 1 unit to the right, up, left, and down. Here we have a center at -5, 3. And the radius squared equals 9, so the radius is the square root of 9, which is 3. So we're going to go 5 to the left, 3 up, and we'll have a radius of 3. This last one has a center at -2, -6. Has a radius of 5. R squared is 25, so the radius is 5. This scale, notice that each bar is going by 2 in this case, and going down by 2s. So when I go to the left and 6 down, we're going to go to the left and 2, 4, 6 on the way down. Then we'll have a radius of 5. 2, 4, 5. 2, 4, 5. 5 will be halfway between 4 and 6. 2, 4, 5. 1, 2, 3, 4, 5. For number 36, we're talking about a word problem that has to do with commuter trains, and we have zone 1 that has a 3-mile radius. So from the center of the city, we do 3 miles in every direction. So zone 1 would fall within this circle. Zone 2 would be within that 3 miles up to 7, so we're looking for a radius of 7. So this middle portion in between these two circles would be considered zone number 2. Anything outside that zone, outside that donut shape, would be considered zone number 3. Now what we're looking for is to find which zone the people live at. So if we're at 3 over and 4 up, 3, 4, that's in zone 2. Six, 5. On my picture, that's looking like it's outside. For 6 comma 5, we would be in zone 3 because we're outside the circle. Then we'd have 1 comma 2. That's in zone 1. 0 comma 3. You're right on the edge. We would still call that zone 1. And then 1 comma 6. That would be obviously in zone number 2. A CD has a diameter of 4.8 inches. The diameter of the center hole of a CD is 0.6 inches. We're supposed to write the equation of the circle that represents the CD and then represents the hole of the CD. So when we write a equation of a circle, we need to know a center, which we're going to call 0, 0, and we need to know the radius. So if the diameter is 4.8, we're going to divide that by 2 to figure out the radius. So we're going to get 2.4. And when we square that, we get 2.4 squared, so we're going to get 5.76. So our equation is going to be x squared plus y squared equals 5.76. And then when we have the hole of the CD, it has a radius of 0.6, or has a diameter of 0.6, so we have to divide that by 2 to figure out the radius, so that's going to come up to be 0.3. And when you square 0.3, that's going to be 0.3 times 0.3, which is 0.9, but you move the decimal spot over 2, so it's actually 0.09. So now we have x squared plus y squared equals 0.09. Those are the equations of the circles that represent a CD, the outer edge and also the inner circle of a CD. Last problem. I'll put it together right here. For number 42, we have these cell phone towers, and they're located throughout the city. The first spot one is located at is at 0, 0, and it has a range of 3. We have another cell phone tower located at 0, 5. 0 right and left, with a radius of 3. And then our last cell phone tower is at 6, 3. And it has a radius of 3. So those are our towers. Now what we're supposed to look at is, are there any areas that may receive calls from more than one tower? And that would be this portion right in here. That anyone living inside that location would receive calls from both towers. Small area from both towers. Suppose your home is located at 2,6 and your school is at 2.53. Can you use your cell phone at either or both of these locations? So 2,6. That's your home. So yes, we can use our cell phone there because we're right in that circle. 2.5, 3. Right there, that's a hard call. Maybe we're right on the edge. Maybe you can use it. I put my dot, it looks like outside that circle, so that would be pretty close. The home could use the cell phone, but school is on the very edge. Since we're just drawing it by hand, it's a little hard to tell if we would be right on that or not. Last question. The city is located, or city A is located at -2, 2.5. And city B is at 5, 4. That's city B, that's city A. Each has a radius of 1.5. Which city seems to have better cell phone coverage? Well, it looks like here city B is inside this circle, but city A has a lot of area that is outside the two cell phone coverages. City A is outside the phone coverage, or parts of city A. Are outside the cell phone coverage. All of city B is in the phone coverage.